Let's see how to enter anchors in CYPE Connect. Starting from a previously created node, we select it in the table on the left-hand side of the interface and edit the connection by clicking on the corresponding button at the top. In the Connection pop-up window in the Model tab, we must specify the operations needed to define the connection. In this example, a plate has been added to the base of column C1, and an adjustment operation has been carried out on it to modify its geometry and enter the welds between the section and the plate. Now we are going to enter the anchors that allow the connection between the plate and the concrete foundation to be solved. To do this, we click on the Anchors option in the top toolbar. First, we specify the element where the anchors will be defined, which can be a plate or a section. In this case, we select Plate and choose the available plate in the drop-down menu on the right. Next, we decide whether the concrete is defined in the element or whether we want to make a selection of a concrete element entered in a separate operation. Below, in the Anchors section, there is a table where we define the number and position of the anchors. To define the position of the anchors manually, we click on Add and enter their X and Y coordinates with respect to the local coordinate origin of the element. With the tools at the top, we can copy, delete, move, or delete all the elements in the table. We also have a tool to generate anchors automatically. The help image that appears when clicking on it displays the local axes of the element, the x-axis in red and the y-axis in green. In the different fields, we can type in the number of rows and columns for the anchors, the initial spacing of rows and columns, and the separation between rows and between columns. By clicking on Accept, the anchors appear in the table, where we can modify their coordinates if necessary. Then, we define the type of anchor. By clicking on the button on the right, we can select the series and the diameter from those available. After clicking Accept, we can click on the button with the name of the series and the diameter to modify its features if desired. Among them, first of all, there is the reference to the series. Then, for the bolt, we type in the reference for the series and the nominal diameter as well as its value. For the nut and the washer, we type in the series references and the nominal diameter again, and then specify the outside diameter, the internal diameter, and the thickness of each one. In the following section, we indicate the anchor's material. In the same way, by clicking on the button on the right, we can select a material from those available and then click Accept. If desired, by clicking on the button with the material name, a window appears where we can modify its reference, description, modulus of elasticity, yield strength, and fracture limit. Additionally, we indicate the material for the nut and the washer. Below, we type in the value of the space between the anchor and the element. We can also reverse the direction of the anchor by checking the corresponding box. Two drop-down menus then appear to define the type of anchor. In the first drop-down menu, we select the type of anchor for the bolts with the plate. The installation can be aligned with a simple washer and nut, aligned with a spaced welded bolt, or spaced with a nut and washer. In the second drop-down menu, we select the anchor in the concrete. This can be straight, with a simple washer and nut, with a double nut, with a 180-degree hook, or with a 90-degree bend. Depending on the anchor type selected, the program will ask us to define the LN, L1, L2, D, and H parameters, which refer to different geometrical dimensions. To help us to find them, the program offers a help image by clicking on the corresponding button at the top right of this section. Further on, we can enter a layer of levelling mortar between the element and the concrete, stating its thickness. The last section allows us to define the anchor's concrete if we have previously stated it. To do this, we specify the material. If we have defined any concrete in the library, we can select it by clicking on the button on the right. In any case, by clicking on the central button, we can enter or modify the reference and the description of the concrete, as well as parameters such as the compression resistance, the compressive strain in the concrete at maximum stress, and the ultimate compressive strain of the concrete. Finally, we define the geometry of the concrete volume by typing in the 4 overhangs: top, bottom, on the left, and on the right, as well as the thickness. From here, once the model is finished, we can continue our work by opening the Analysis tab to analyse the connection.